about all 6 trig functions now that you've learned all of them. Okay, so this is going to be a recap here. First of all, let's talk about sine and his reciprocal cosecant. Sine starts at the origin. Okay, think about your spaghetti. Up, down, down, up. Cosecant are the parabolas that you draw. You put asymptotes wherever it touches 0, and then you go ahead and put the parabolas either opening up or opening down, approaching those asymptotes. Okay, I'm going to color code this here. I'm going to do sine in blue, and the cosecant is in pink. All right, let's talk about cosine and his buddy secant. So cosine, let's do this one in blue. Cosine does not start in the middle. He starts up at a maximum and goes down, down, up, up. Okay? That's one complete period for cosine. And now let's talk about secant. Secant is the parabolas. Make sure we put the asymptotes wherever cosine touches 0. There's one parabola. Here's a half. Here's a half. There's 2 parabolas. 1 period of secant. Okay, how does tangent start? Tangent on the y-axis gets a point. And he looks like a cubic, and his asymptotes are on either side of the y-axis. How does a cotangent graph look? Cotangent starts with an asymptote, then his point is off to the side, and he is a cubic that's reflected. So here are the 6 trig graphs. Now let's talk about them. How do they start? Okay, I'm going to color this in blue. Sine starts at a middle. Cosecant is going to do whatever sine does. Okay, cosine does not start in the middle. He starts either at a maximum or a minimum. So let's put at a maximum or slash a minimum, depending if he's positive or negative. If sine is negative, he would just start going down, but he still starts in the middle. How does it start? Tangent on the y-axis gets a point. He gets a point on the y-axis. And how does cotangent start? He gets an asymptote on the y-axis. Okay, how do we calculate period? For sine and cosecant, it's 2 pi over absolute value of b. For cosine, it's 2 pi over absolute value of b. For these two guys, it's the same. It's pi over absolute value of b, pi over absolute value of b. How many sections do we divide them into? For these two guys over here, it's 4 and 4. For these two guys over here, it's 2 and 2. Okay, which ones have asymptotes? Does sine have asymptotes? No, but cosecant does. Secant does. Tangent does. And cotangent does. The only ones that don't are sine and cosine. But all of these have breaks. Which ones have domain all reals? Well, I think it's going to be sine and cosine, because they are smooth and continuous forever. Now, this is all the stuff that you should know and think about when you're drawing a graph. We'll do a couple of review problems here. This one looks really good. It's got a lot of fractions in it, so let's make sure we do the right formulas at the right time. First of all, cosecant goes with sine. So I'm going to think about 7/9 sine of 2/3 x. So let's calculate the period. We have to take 2 pi, and divide it by b, which is 2/3. That's like multiplying by 3/2, so the period is 3 pi. How about a section? Should I divide that by 4 or by 2? I should divide by 4 because it's sine. 3 pi over 4. Okay, let's go get our graph started. This is a cosecant, so I'm going to have to do a sine and then put the parabolas above and below. So we're going to have to maybe scale it down a little bit. Don't draw a huge sine. You won't have any room for your parabolas to go. All right, let's see. 3 pi out of 4 plus another 3 is 6 out of 4. Or 3 pi out of 2. 3 out of 4, 6 out of 4, then comes 9 pi out of 4. That's the trickiest one right there. That one right there tells me if you're adding fractions the right way. 9 plus 3 more is 12. Divided by 4 makes 3 pi. Did it work? Absolutely. All right, let's go to the left. Negative 3 pi over 4, negative 3 pi over 2, negative 9 pi over 4, and negative 3 pi. All right, let's talk about a sine graph. The amplitude for sine would be 7/9. So let's go up about 7/9 there, down about negative 7/9. Okay, and any reflecting for the sine? No reflecting. Okay, we're ready to start. Start in the high, middle, or low. Let's start in the middle for sine. And he goes up, down, down, up. This way's going to go down, and this one's here is going to be up. Okay. Now let's talk cosecant. Cosecant is going to have a problem. He's going to be undefined wherever sine touches 0. So let's go ahead and put some asymptotes here. Wherever the sine graph touched 0. Y-axis, 3 pi over 2, and a 3 pi. All right, I think we're ready for cosecant now. Anybody have a maximum? Put a point, touch it, they actually connect, and then draw the parabola approaching the asymptotes. Make sure these points connect. There is no space. Sine and cosecant, they meet up. Put the point right on the parabola. There should be no gap. Okay, do I have 1, 2, 3, 4? 4 parabolas make my 2 periods. Domain, all rails except, where's the first break? X cannot equal 0. If you want to write 0, go ahead. Plus or minus, the space to the next one is 3 pi over 2n. The range, make sure you're looking at the blue cosecant. Everything else is dashed. That's not graph. The blue is the only graph. From negative infinity up to negative 7/9 bracket, and then continue 7/9 up to infinity. Are there asymptotes? Of course. X equals, the first one's at 0, plus or minus 3 pi over 2n. Does cosecant touch the x-axis? No, you put a dash. Okay, nothing new here, just kind of recapping so you know how to do all 6 types when we mix them up. Let's review a tangent graph. Okay, so now we have to make sure we use the right formula for period. Tangent and cotangent have formula pi divided by b, which is 5/2. So let's go ahead and simplify that. Dividing by 5/2 is like timesing by 2/5, so 2 pi over 5. Now let's figure out a section. You take that period and you're going to divide it by how many for tangent? Divide by 2. That makes pi over 5. Okay, let's go get our axes drawn. Tangent and cotangent are rather short and sweet. 1 pi out of 5, 2 pi out of 5. Did it work? Perfect. Negative 1 pi out of 5, negative 2 pi out of 5. All right, let's remember, how does a tangent start? On the y-axis, he gets a point, and then the asymptote, and then a point, and then an asymptote. Every other one. Okay, let's think about tangent. Oh, I've got to do some vertical stretch. Which means I'm going to have to do a dotted basic, and then I'll do a stretchier one. Oh, and a negative, and reflected. So let's just remember, a tangent graph looks like a cubic. So I have to reflect it, and it's going to look like this. Down, down, down to the right. Down, down, down to the right. Down, 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 hit the point to the right. This is where you want to make sure you've got the same picture every time. Down, down to the right. Okay, I've got the reflection. Now let's do the stretchy. The stretchy one's going to be above that branch. Above that branch, farther from the x-axis. He's higher. He's taller than the basic one. There you go. Domain is all reals except x is not. The first asymptote is found where? Pi over 5. Plus or minus, the space to the next asymptote is 2 sections. You can think 1 out of 5, 1 out of 5 makes 2 out of 5, or you could just slide your fingers down and say, oh, 2 sections is 2 pi over 5n. Range for tangent and cotangent, all reals. Does he have asymptotes? Of course he has asymptotes. The first one is, again, I'm just going to copy this here, at pi over 5 plus or minus 2 pi over 5n. Does he have zeros? This is where it gets different. Yes, there are zeros. The first one is 0. If you like to write 0, go ahead. Plus or minus 2 pi over 5n. Okay. Let's just go ahead and recap all 6 of these one more time so we can kind of look to see what do they look like. Okay, for the last time, how does a sine graph start? He starts on the origin. Think of your spaghetti, and he's going to look like that. Okay, a cosecant, let's go ahead and draw a dotted sign, and he would have the parabolas added on top or below. So that would be the cosecant. All right, what does cosine look like? Cosine starts up at a maximum. So cosine looks like this. Down, up, down. Oh, why am I doing it dotted? Cosine needs to be solid. Sorry, cosine should be solid. The secant down here needs a dotted cosine. Dotted cosine down here, and here's where I'll add on the parabolas. Secant gets parabolas. Do you want to add in the asymptotes on the zeros just to make it more neat? Sometimes too much doesn't look neater. Okay, and what does tangent look like? Tangent starts with a point. He's got asymptotes on either side, and he looks like a cubic. Cotangent starts with an asymptote, and he's on either side going like that. The point is in the middle. Okay, now I want you to study these 6 graphs so I can ask you some questions. Even functions. Oh, this is chapter 2. Even functions are symmetric over the even. Think of x squared over the y-axis. If you fold on the y-axis. So which of these graphs are even? If you fold sine, I don't think those are going to match. Well, neither that one. Ooh, this one would match if you fold a secant. You fold on the y-axis, so we've got cosine, and we've got secant. If you fold these, do they match? Nope, they don't match. What, are you sure? Oh yeah, that branch will be too close. Okay, let's talk about odd. I remember when we studied this back in chapter 2, we were making fun of each other because odd are symmetric over the origin. And how do you do that? You turn the paper upside down, spin it 180 degrees, and see if it matches. So go ahead and turn your paper upside down. Do any of them look like mine? Does sine look the same as your paper? Yes, that one is odd. And of course, if he is, then his reciprocal is. Okay, so these two are odd. These are not matching. How about these guys? Does your paper upside down look like these? Yes, they do. So we've got sine, and of course, his buddy, reciprocal cosecant. And if tangent does, then so does cotangent. Okay, that is all 6 graphs, and I hope you're doing good.